Hello viewers, let me welcome once again to this session of discussion. In the previous session, we have given the magnitude of charge of the electron and proton, and the charge of the electron is negative and that of the charge of the proton is positive. By virtue of their charge, we want to see what is the type of interaction they have. To know the type of interaction between electron and electron, electron and proton and proton, we have to define what is Coulomb's law. Now, let us see what is Coulomb's law in electrostatics. It states that the electrostatic force Fe between two point charges Q1 and Q2 is directly proportional to the product of the strength of the two charges and inversely proportional to the square of the distance between them. That is mathematically Fe proportional to Q1 Q2 proportional to 1 by r square implies Fe proportional to Q1 Q2 by r square. So Fe is equal to beta times Q1 Q2 by r square, where beta is a constant of proportionality which you determine later on. So this equation 1 gives you to calculate the magnitude of force between two point charges Q1 and Q2 at r distance apart. Even if Q1 and Q2 are given, r is given, Fe can be calculated unless you know the value of beta. The question is, what is beta? Beta is a constant, no doubt, but it is a constant for a given system and for a given medium. And the value, let us see, in SI system for air medium, the beta is given 1 by 4 pi epsilon 0 is equal to 9 into 9 Newton meter square by Coulomb square, where epsilon 0 is 8.854 into 10 to the minus 12 Coulomb square by Newton meter square, and is known as permittivity of air or vacuum. This is one of the electrical property of air and the same as vacuum. Now, using the value of beta, equation 1 becomes Fe is equal to 1 by 4 pi epsilon 0 Q1 equal to by r square. So, equation 2 is the mathematical formula for Coulomb's law to calculate the magnitude of the force between them strictly for air medium and in SI system. So, to use equation 2, we have to see Q1, Q2 must be measured in Coulomb, R must be measured in meter. So Fe can be calculated in Newton. Let us see how this force gets modified when the interference medium is replaced, the air medium is replaced by some other direct medium, that is paper, mica, water, etc. Remember, paper, mica, water, these are insulators, but they are called dielectrics. All dielectrics are insulators, but all insulators are not dielectric, and we will discuss later on. For any other dielectric medium, beta is replaced by 1 by 4 pi epsilon, but epsilon is called the permittivity of the dielectric medium. This is also the electrical property of that medium. So using value of beta, equation 1 becomes Fe dash is equal to 1 by 4 pi epsilon Q1 Q2 by r square. If you compare equation 2 and 3, then Fe by Fe dash comes as epsilon by epsilon 0 is equal to epsilon r is greater than 1, where epsilon r is called the relative permittivity, that is permittivity of the medium relative to vacuum. And Fe is the force between the two point charges are at distance apart when the intervening medium is air or vacuum, and Fe dash is the force of interaction between the same two charges at the same distance separation, but the intervening medium is other than air. And since epsilon is greater than epsilon 0, epsilon r is always greater than 1, so this indicates Fe is greater than Fe dash. And also the relative permittivity is equal to K, where K is known as dielectric constant of the dielectric medium. So in terms of K, we can write Fe by Fe dash is equal to epsilon r is equal to K, where Fe is equal to K times Fe dash. Now let us see what are the corresponding values in series system. In a series system for air or vacuum, beta is taken as 1 times Newton square by start from square. So equation 1 becomes Fe is equal to Q1 Q2 by r square. So if you use equation 4, Q1 and Q2 are measured in start Coulomb, r is in centimeter, Fe will be calculated in dye. So for any dielectric medium, beta is replaced by 1 by k, where k is a dielectric constant. Hence the equation 1 becomes Fe dash equal 1 by k Q1 Q2 by R square. If you want to compare Fe with Fe dash, then Fe dash is equal to k, where k is known as dielectric constant. So in these discussions, we have seen that the force of interaction between two point charges in air or vacuum is greater than, is k times greater than the force of interaction between the same two charges when they placed at the same distance apart, when the interfering medium is other than air, than other dielectric medium like paper, mica, water, etc. Now, these equations will give us to calculate the magnitude of force between the 2 point charges in the different systems and for different intervening media. Now, using these relations, we can now calculate the electrostatic force of interaction between electron, proton and proton. But to complete it, let me write this equation, giving it equation 1 in a vector form, and that will be discussed in the next session. Thanks.